Hi, this is Mrs. Benke, and this screencast is on graphs and tables and how we will be using them in the chemistry classroom. So let's start with a quick review. First of all, we want to remember that the graph is made up of two axes, the x-axis and the y-axis. The x-axis is our horizontal line, so it runs from left to right, and it is where we plot our independent variable. The independent variable doesn't change based on any other variable, it just changes on its own. So in this case, dealing with time, time doesn't change because the speed changes, it just changes naturally on its own. The other axis is the y-axis, which is the vertical line or the up and down line, and this is where we plot our dependent variable. The dependent variable changes because of the independent variable. So in this graph, the change in speed, it changes because we've been able to move at a longer time. So it changes because of the time. Okay? So in chemistry, there are two main graphs that we will be taking a look at. We will use a line graph, which it shows information that is connected in some way, usually a change over time. In a line graph, you can have multiple lines. This particular graph shows one line, but you can have multiple lines on a line graph. And as I mentioned, it is frequently used in science. In a line graph, you do want to follow the acronym SALT, where the S stands for scale. Okay, so here we see that in our scale, each square is represented by 1 year. Okay, as we go across the x-axis. As we go up the y-axis, each square is represented by 100 teens. Okay, so it's the scale is correct. It makes sense. The axes are labeled. They're labeled with a title. And the graph also has a title, Small Town Teens with Cell Phones. So you want to make sure that your graph is scaled correctly, that the axes are labeled, that there are units if units are appropriate, and that there is a title for your graph. Also note that in the line graph we have data points, and these data points are connected with a line. The line may be smooth and continuous, or it may vary up and down like we see here in this graph. The other type of graph that we use commonly in science is a scatter plot. This is a graph of plotted points that shows the relationship between two sets of data. The data is plotted on the graph as Cartesian coordinates or XY coordinates. The relationship is not always perfect in these graphs, but typically there's a general trend line. So if we look here at this graph, we can see that in general the data shows an increase, but some of these data points kind of fall out, like right here, this data point, it drops down a little bit. So it's not perfect, but we can find a general trend. Sometimes with a scatter plot, we want to find the best fit straight line. This can be referred to as the best fit straight line, the line of best fit, or the trend line. And we see that here in this graph where we have this straight line drawn between these data points. In general, you want to try to have the line as close as possible to all of the points, and you want to try to have as many points above the line as below the line. So if you're doing this by hand, you want to plot all of your points on a graph, and then you want to take a ruler and you want to move it around so that you're basically finding the average of the data. Your line should represent the overall average of the data plotted. If you're doing this on a computer, you're fortunate because the computer will draw the best fit line for you. But again, if by hand, you need to manipulate the ruler to find the best average line. When we make a graph, we can interpolate and we can extrapolate data. Interpolation is where we find a value inside of our data set. So if we look at this graph here, okay, we see where the points are plotted. Those are the circles. So they're calling them the tabulated values. Those are the actual measurements that we took. But notice we don't have any actual data for the air velocity of 500. But if we go up to that point on the graph and we want to find thermal resistance, we can still find it even though it's not an actual tabulated value. That's interpolation because we have data points above and below that value. So it's within the data set. Extrapolation, on the other hand, is where we find a value outside of our data set. So here we see our data goes from a temperature of 12 all the way up to about 25. But if I was looking for what would the value be at 29 degrees Celsius, that's beyond my data set. So I need to extend my data line so that I can estimate what that value would be. Both interpolation and extrapolation are estimates. The only difference is that interpolation occurs within our data set and extrapolation. extrapolation occurs outside of our data set. Based on graphs, we can also determine proportionality. So there are direct proportions and there are indirect proportions. So in a direct proportion, both variables change in the same manner. So by that I mean both variables increase or both variables decrease. Two quantities are directly proportional to each other if dividing one by the other gives a constant value. So when we're looking at a graph, a direct proportion would be shown by the line sloping upward, as we see here in this example. The opposite of direct proportion is indirect proportion. And in this case, the variable changes in opposite directions. So as one variable increases, the other decreases. Two quantities are inversely or indirectly proportional to each other if their product gives a constant value. So key here is that indirect and inverse mean the same thing. So as we look at this graph, we can see as I increase the volume of the gas, I'm decreasing the pressure. Okay, so I increase the volume, I decrease the pressure. If I decrease the volume, I'm increasing the pressure. So they're opposites. They're changing in opposite directions. Tables are pretty simple in science. They're used for recording and organizing information. The key here is that you need to make sure that your tables have a title, that they have labels with units, and that they have data. Typically, we don't include the units in the table. So here we see average plant growth in centimeters. We don't have 25.4 centimeters, 33.0 centimeters, 50.8 centimeters. We keep the unit up at the top with the label for that column in the table, and then we just note our numbers in the table. So make sure whenever you're using graphs or tables here in science that you have a title, that you have labels, and that you're including your units. Please make sure to show your notes to Mrs. Benke for credit for watching this video.